All right, well, welcome everyone to the October webinar, the Pure Filtration webinar. Today we're going to talk about mastering indoor air quality and some of the advanced solutions across the industries, that we see and that we manufacture and produce here at PureAir. Again, just a quick introduction of myself. My name is Anthony Yamini, the VP of Sales and Business Development here at PureAir. I have been with PureAir for 17 years and been in the gas phase filtration industry for over 23 years. So still really enjoy what I'm doing and looking to innovate and just have fun. So with that said, we'll go ahead and get started uh, with this presentation. And if there's any questions, you can definitely answer those. Just put any questions in the chat. And at the end of the presentation, we'll go ahead and read those and work at answering those questions if there are any. So with that, we'll go ahead and get started. All right, so for this presentation, we're just kind of going to start out here at the table of contents. We're just going to start, just kind of introduction to pure filtration. For any attendees that have previously joined our webinars, welcome back. And also some of this information might be you've heard in prior webinars. So definitely this could be a nice refresher. But for those that are new, I hope this information is informative. So again, we'll just, introduce pure air filtration some, talk about gas phase filtration and what that is, talk about the IAQ commercial markets and then some of the solutions, some of our notable projects and customers. We have a case study we want to talk about, and also uh, introducing our lifeguard bed monitoring system. So, really, it's a nice, should be a great presentation, very streamlined, and should be informative. All right, so Pure Filtration, we are located here in Atlanta, Georgia. We have been in business now since 2004. So celebrated 20 years in the industry in February of this year. So, looking to be here another 20 years from there. Uh, we have more than 50 employees here at PureAir, and we actually have sales in over 60 countries around the world. And as of 2023, we are now officially a woman-owned and operated business. So that's a great benefit, a great achievement for the company to allow us to, have advantages in certain bids in different markets. And I also want to mention we are also BABA compliant. And that is the Buy American, I forgot the rest of it. Buy American Act. So that's starting to gain a lot of traction. It's becoming a requirement. So that's something we can provide systems that are BABA compliant. So I just wanted to mention that. One other thing that's very important as well with pure air filtration is that we are a single source manufacturer. So we provide the gas phase filtration systems, the chemical medias, and all the monitoring tools. We're also ISO 9001 certified company as well. So that's going to ensure that we have, top quality products that are going to perform very well. And as I mentioned, sales to over 60 countries around the world. So we're very proud of that. We are looking to just expand and really just working hard at expanding our footprint throughout the globe. So pure air filtration, we work in five main industries. So we have odors and emission control. I would say that's probably the bulk of our projects at the moment. And so that is odor control applications for either municipal wastewater or industrial wastewater. So we can provide, high efficiency systems, removing different wastewater gases that may be in the airstream. uh, Toxic gas protection. So that would be emergency gas scrubbers. So very low maintenance systems. They're used to capture accidental releases of any stored gases or stored toxic gases, primarily chlorine gas. So if there's any accidental release, the systems will activate and neutralize that gas. Uh, Protecting electronics. That's one of the industries where uh, those odorous gases are also very corrosive. So we need to, it's important to protect control rooms that may be in the either whether it's a wastewater plant or any type of, chemical plant or paper mill. So you want to protect that expensive electronic equipment from those harmful corrosive gases. So we can provide systems to purify those control rooms to protect those systems, protect those the electronics. Biogas and sour gas. It's a fairly new industry for PureAir, where we can remove very, very high levels of H2S. Typically, we've worked a lot with dairy farms where they digest cow manure and they want to produce or capture the methane gas, and they sell that back to whether it's the state or cities or different entities, but they have to get rid of the H2S while they do that. So we can provide the medias to remove that H2S gas. Typically, those specialized medias, they are designed to remove, you can remove up to 7,000 ppm of H2S. So, and then for this discussion today, we're going to discuss indoor air quality. So that's going to be the topic, and that is, in essence, what we're doing with indoor air quality. Just improving the air quality inside of buildings, whether it's museums, hospitals, different office buildings. So that way, just improving that air quality inside, from the ambient air outside. So we'll touch on that a little bit more here. All right, so gas phase filtration. So what is gas phase filtration? It actually has a few different names, whether it's chemical filtration, which is a popular term in the most widely used term in the Middle East, but also be airborne molecular filtration or gas absorption. So in essence, what we're doing, we're removing very, very small uh, contaminants from the airstream. It's even smaller than dust particles, really molecules. That's what gases are, very, very small. So we need to capture those gases before they exhaust out into the airstream. So gases, like as I mentioned, they're very small. They are about, say, 0.0003 to 0.007 microns, very small. And just to give you some context, human hair is about 100 microns. So kind of gives you an idea of how small those gases are. And with that, a mechanical filter that you would use in your furnace at your home, those gases will pass right through that filter. So you need something that's going to capture those gases and something that's small. So again, some of the common gases we're going to remove is, hydrogen sulfides, some sulfur dioxides, other gases that are present just from different applications, the VOCs as well. Wanted to show this illustration here as it shows the principles of gas phase filtration. So in essence, you would have consider this a media bed filled with adsorbent media. You have the contaminated air coming into the system. Uh, of course, this media is already used up. So this area here called the active transfer zone, this is what's doing all the work. So we actually call it the working zone. So this working zone will move in the direction of airflow until all the media is consumed. So we have the air coming in, spent media. This area is doing all the work, still have unused media, and then that transfer zone will make its way until the entire bed is consumed. This is important for our systems because we can actually monitor and track this transfer zone. That's very important for our media monitoring devices that we will discuss here later in this presentation. So two types of gas phase filtration. So you have adsorption and also chemisorption. So adsorption, that media would be, say, example, activated carbon. So really think of it as a sponge. So activated carbon is very porous. So as the gaseous molecules come in contact with the media, it's going to hold it in place like a sponge. So just like a sponge holds water, activated carbon will hold the gases in place. Uh, Now, this process is reversible, just like a sponge is. So if you squeeze a sponge, the water comes out. Well, there are ways to reverse the media, the carbon, for like reverse the spent carbon. Two couple of ways that it's done using water to wash off the contaminant or impregnate, or in some cases you can use heat to burn off the gases from the media. And in some cases, you can reuse the activated carbon after it's been regenerated, so to speak. It does lose some of its capacity when that happens. So typically, when most end users would recommend, they usually want virgin carbon for most of their applications. Chemisorption is very similar. It's still very similar. It's an adsorption, but the process is very specific, and it's really it's dependent on a chemical to end both the absorbent media. So for as an example, we would use activated alumina as the substrate. It's also very porous, but that media is impregnated with a catalyst that's going to react with the gas that we are targeting. So once that uh, the gas interacts with the catalyst on the media itself, there's a conversion, and actually uh, that chemical reaction, that oxidation, it just converts the corrosive gas and the media into an inoffensive solid. So it can just be disposed of uh, in typical, just disposed of like ordinary waste, and it is non-toxic. But that process is permanent and it's not reversible. So once that media is used up, it has to be disposed of. So IAQ in some commercial markets. So they're about, uh, oh, there we go. So some of the markets that we see in that may have some indoor air quality problems where we'll kind of touch on some of those a little bit deeper here in the presentation. We have museum and archive, so we want to protect precious artifacts. Hospitals, you want to ensure the patients and the workers, healthcare workers, are protected from any harmful gases or just chemicals that are in the hospitals, or even in some cases just germs as well. Casinos and hotels, just the constant smoke smell. That's one item that I really recall when it comes to casinos. Just constantly, there's a lot of smoking, and just that air just seems to be thick with the smell of smoke. Airports, you want to just eliminate jet fumes that may be in the concourses, as well as just overall just human traffic as well. Restaurants, and looking to eliminate some of the food smells that may emanate, from the buildings, or even on the inside. We'll discuss that as well. Uh, and also office buildings, used with employee comfort and safety. So just have the nuisance odors and smells that may be uh, in office buildings. So yeah, as I kind of mentioned, one thing I want to mention about restaurants, in some cases, depending on where it's located, uh, some may like the smell of certain foods, but in a lot of cases, it's really unwanted. So that's really the importance of having some type of, uh, odor removal or some type of gas phase filtration system to remove those different smells. And I kind of touched on museums, hospitals, casinos, and so we'll go from there. So indoor odor sources and contaminants. So I would say these, the sources seem very harmless, but there are some pretty offensive gases that just come from everyday products and materials. So you look at it, these carpeting, you have, formaldehyde, xylene, and other VOCs that are just emanate from the glue that's used in some cases to hold down the carpeting, or from the carpet itself. And also caulking compounds, you cooking, you get the sulfur dioxide, nitrogen dioxide, adhesives, plywood and chipboard, cleaning products, of course, you have the ammonia and amines, and also formaldehyde, other VOCs. So, quite a few sources, even in your building, that you really don't think about, or any indoor facility. It really doesn't, most people don't really think about, but those gases and contaminants are present. So in some cases, if you need that purified air, you need to ensure you have some system in place to do that. And here are some of the corrosive gases. These are most common, especially in the protective electronics industries that one of our core industries here at PureAir. So you see the hydrogen sulfide, sulfur dioxide, nitrogen dioxide, chlorine, uh, hydrogen fluoride as well, hydrocarbons, like some very corrosive gases. And so it's very important to select the proper equipment to make sure we're removing those gases. All right, so how can gas phase be used? We'll kind of touch on, some of the different, ways that we can use it. So again, improve general indoor air quality, removal of odors and kitchen exhausts, or other odor sources, and preventing odors from entering adjacent buildings, protecting valuables in museums and archives, and reduce energy consumption and protecting mission critical electronics. So for just improving general indoor air quality. So there's a couple methods that we could use to, for that, where if we bring in any outside air, there's outside air intakes on a building, so we can actually place a chemical uh, gas phase filtration chemical filter on the air intake to purify the air before it comes into the building. So in some cases where it's an office building or even a hospital or airport, where we've seen applications where the air intakes for a building were pointing at a helicopter pad. So as the helicopters are there, that the exhaust fumes, they would be sucked right into the building. So in those cases, so it's harder to redesign the building at that point because it's already built. So in those cases, you can actually install a system on the air intake to purify the air, remove those gases before it comes into the building. Uh, Recirculation. So that's those systems. And so in essence, you're not bringing in any outside air, but you want to clean the air in the building that's already there. So whether you had the formaldehyde or different gases that was shown in the previous slide that are just from common uh, building materials and furniture and carpet, that you have those gases. If you want to keep those areas clean, you can provide we can provide recirculation systems that'll just turn the air over in those rooms in those buildings to ensure uh, you got clean air inside the space. Kitchen and odor exhaust. So again, I kind of touched on that briefly in the previous slide, but these systems are very prominent in the Middle East. They have starting to have a lot more of these seven-star hotels are becoming more common. So they don't want any of these smells in the hotel lobby. I personally think some of the smells are wonderful, but it doesn't go sometimes those smells don't really fit the narrative or the vision that they have for their hotel. So in those cases, we would need to provide a system that would attach to the exhaust hood over the kitchen, so to purify the different or to eliminate those different gases from there. Uh, so those systems, various configurations for that, where you want to remove, because you will have a lot of smoke and grease from that application. So you got to ensure you provide the proper construction of the system, as well as the different components to remove the different, uh, there are methods for moving smoke, the grease, and of course the actual gases themselves, or the odors themselves. So we'll talk about that a little bit more here moving forward. Museums and libraries, as I mentioned, definitely want to protect valuable artifacts. We have systems at the National Archives in Washington, D.C. So, purifying the air will ensure just the long-term protection of the artifacts. Because if you ever notice with the newspaper, over time, newspaper will turn yellow. So, and that's just from just airborne pollutants in the air. I mean, actually human oils and just from touching the newspaper over time it turned brown. So that yellowish color. So it's important to keep the air really super purified for museums and libraries and archives to protect them. And protecting mission critical electronics. So like I said, very expensive electrical equipment in a lot of these control rooms at different plants. So so without any protection, those copper and silver sensors, they actually are very susceptible to corrosion. So over time, that corrosion will build up and cause some short circuiting, and therefore you have to replace the equipment. So some cases, you know, the electronics can be worth millions and millions of dollars. So if you can provide just a good system in place to keep that air clean, that actually will provide some great savings and prevent any downtime uh, at these plants. I was told that paper mills, if they're down for any amount of time, I want to say it's in the millions of dollars, per day uh, that they lose on money when they have any downtime. So it really shows the great importance for ensuring that those systems don't go down. And energy savings. So, in essence, in a lot of the office buildings, the less energy that you use conditioning the air, that'll help, save money because as you bring in outside air, that has to be conditioned, whether it has to be cooled or heated, or moisture has to be removed, or the humidity needs to be conditioned. That's going to cost extra resources, extra money. But if you're able to use just the existing air in the system, by whether that's recirculation, uh, that'll help, with some of the energy savings, and you just reduce that air intake that you have to bring in. All right, so now we'll discuss some of the different equipment that we use for gas phase filtration. So here, we have quite a few systems that we're not really showing here, but for indoor air quality, I would say these are probably the most common that we would use. So deep bed systems, these are primarily used for protecting electronics in those applications, just due to the higher levels of gases. You can have much higher levels of those different gases in those applications. So with those systems, the media is just loose filled into the vessels. You just have that bulk of media. So the air comes through, it's purified and exhausted out. Uh, and that's a couple of systems that will be most common for indoor air quality, protecting electronics, drum scrubbers or our packed bed scrubber systems. Side access housings, so they will resemble, and they're designed to mate up with existing air handlers or existing ductwork. So it's going to follow the ASHRAE sizing for duct and air handlers. So the media for these systems are contained in cassettes, and so they are designed for the higher velocities. So that way, in most cases, air handlers are designed for either 500 feet per minute or 250 feet per minute. So those we can size those side access housings for that. The kitchen ecology system would be considered a side access housing. Uh, so again, these systems are designed for higher velocities, but they are not the optimal choice for high gas applications, but they're mostly ideal for IAQ, for indoor air quality applications. Uh, and then package filter units, very similar to the side access housing, except it's more of in a vertical configuration, but it also uses the cassettes as well. And these are, I'll talk about those a little bit more here in the next couple slides. So for side access housings, they typically are, horizontal airflow, very compact system. It has access doors typically on both sides. That way you have quick access to any filters, media, as well as servicing the blowers. Uh, these systems will handle low to medium contaminant levels. As I mentioned, not ideal for high levels of gases, but your net medium to low, they are pretty ideal. Uh, Typically up to 3 media passes. We have done more than that as a customized solution. Uh, Great seal, so we ensure with a great design, we ensure there's no bypass in the system or around any of the absorbent media. That way we're getting maximum utilization. And as I mentioned, these systems are customizable. They can come in different materials of construction, whether it's aluminized cold rolled steel, painted powder coated steel, aluminum, and different stainless steels. And these systems would range from 5,000 CFM to 40,000 CFM, depending on the application. So. And kitchen ecology systems, as I mentioned previously, outstanding units for removing kitchen exhaust, kitchen odors, and from typically hotels or restaurants. Multi-stage system, really depending on the level of contaminants that are expected. It can be installed with a electrostatic precipitator uh, to capture any, mainly the smoke. Grease filters to capture any grease as well that may be in the airstream. And then we have a couple other different roughing filters as well. And then we also have the most important uh, uh, pass would be the absorbent media. So that way we're taking out the odors. Then typically we'll have a blower exhausting out either this system's on the roof or exhausting out through the roof. Uh, yeah, different configurations. Like again, these electrostatic precipitators can actually be designed as auto wash, so they will actually wash out uh, any of the smoke, automatically if needed. So great systems for uh, indoor for basic kitchen ecology systems and kitchen odor control. In package filter units. So again, as I mentioned, very similar to the side access housing, except it's in a vertical configuration. So these units are standalone. So you can actually place these uh, in a room. They can either be portable, so they can be moved around in different rooms, turn them on, and they actually just filter out the air, recirculate the air in the system. They can be produced to provide pressurization or recirculation or both. So depending on the room size, that'll determine what size system that we would use, for that room purification. So. Now, as I mentioned previously, that for side access housings and as well as the package filter units, PFUs, these are the cassettes in these systems that hold the chemical media. So depending on the velocity that we need or any footprint restrictions, that'll determine, what size system, but we'll either size it for the PP18 modules or the PP12s. So it just depends. Our PFU systems, they all use the PP12 modules that'll slide into the actual unit itself. So the PP12 is a 3-inch tray. It's designed for about 250 feet per minute maximum through the module itself, and it's really for light industrial and low to medium contaminations. The PP18, basically, it's a 1-inch tray and it's sized for 500 feet per minute. And that's mainly for commercial. So we wouldn't use the PP18s in any type of low to medium industrial applications because the media just wouldn't last long enough. And the end users and customers would be replacing the modules quite frequently. These systems are filled here, in-house, and they are disposable. So once the media is used up, you can just dispose of the entire module and with media uh, and just a typical just waste. We'll mention that the pressure drop for the PP12 or the PP18 is much lower than the PP12. So again, depending on the contaminant load and pressure drop requirements, and that'll give us an idea of what would be the best system to use, or best media choice to use. Okay. So, and again, matrix filters, this is another filter that we would use as well. Very highly efficient, really based on the amount of media in the filter as well. And it's great for high velocity applications. So it is a filter, it's a 4-inch in depth. We only provide in 4-inch depth. So it's designed to fit, if there are existing air handlers, it's designed to slide into a 4-inch tray. Dust free, we're using a monolithic carbon structure. So these carbon blocks are built up into a frame, typically a galvanized or a plastic frame with screen. We can customize those sizes depending on what's required in the existing air handlers. Or if we're providing a system, we can determine what's the best size as well. Comes in 3 different types of media for our matrix filters. So you either have the ACX, which is our plain carbon, ammonia Zorb to remove ammonia, or Sulfazorb 2 media that'll remove various gases depending on the application. with no bypass, and it has a very low pressure drop at the 500 feet per minute. So definitely be retrofitted into existing systems. We'll just work with end users, determine, what's the, can really say the maximum capacity or pressure drop or the blower capacity, so that way we can ensure we provide a system, and we won't overload the system. Uh, Yep, easy to retrofit. As I mentioned, limited to three types of media. So in some cases, the matrix filters are great. We need a very tight, compact, highly efficient system. But if we need to remove, maybe some unique gases, we may have to use one of the different cassettes, PP12 or PP18s, so we can actually load that with some of our custom media blends. Here, showing some of the different medias that PureAir manufactures and provide for our systems. So Pure ACX, as I mentioned, that's just extruded activated carbon. Carbon is, it's very become the standard over the past decades. It's low cost, but it's very effective, as well as a coconut shell carbon as well. That's considered, some of the finest in the world for air purification, but has a higher pressure drop. But when it comes to the engineered absorbents, it's typically what we manufacture here, and that's how we can target some of the more exotic and unique gases. So those medias would have different substrates depending on the application. So it could be activated carbon that we would impregnate with the catalyst, but also do activated alumina, zeolites, and clays. So it really just depends on the application. Let us know what media to use. And some of the impregnates in these media is caustics, acids, oxidizers, and catalysts. So we also blend some of the medias as well. So that gives us a very broad acting uh, broad acting gas removal. In most cases, up to 99% of gases it can be removed if we just blend, as example, some of our KOH impregnated carbon, our sulfosorb 2, with the potassium permanganate media. We blend those two together. We call it our PP blend. It's very effective removing a wide range of gases. And also one of the benefits when we blended with some of the purple, as you can see here, that the purple media will change colors as it's being spent. So starts off bright purple, and then it'll go from like a brownish color and it'll turn white. So that kind of gives you an indication on when it's time to change the media. Here's a comparison of some of the carbon versus engineered medias. So won't read all of them off, but just some of the differences. Just carbons, you can't UL certify because it will burn, whereas some of the engineered medias, it is UL certifiable because it won't have that ability to burn. Uh, the gases, when it reacts with engineered adsorbents, just turns into a harmless solid, can be disposed of. You're gonna have higher capacities for different gas removals. As I mentioned, non-hazardous after it's spent. You will have that color change, that color change as well to give you an idea when it's time to change out the media. And it's also easier, for us here in our lab at PureAir to monitor or test the life consumption of the system. So using that engineered media, it's easier to track versus plain carbon is a little more, it's harder to gauge the existing media life. So here's just a few of our important customers that are using pure air filtration media and systems. Very small list. This list continues to grow, but we are working with some very notable customers. So at some point, we're looking to have at least maybe 4 or 5 more slides of some of our different customers we work with. So, but yeah, again, Hilton, Google, Intel, Dannon, Air Force, yeah, just to name a few. All right, we have a case study. We have a project. Actually, it's in Mecca, Saudi Arabia. We have over 23 kitchen ecology systems, at the different Hilton properties in Saudi. So they are uh, really trying to, that's the actually the holiest, uh, let's say holiest city in the Islamic uh, religion. So they're trying to make it even more attractive and really putting a lot of money and effort into beautifying the area. So now there are quite a few five-star hotels that are uh, being built, in Mecca, and not some right, very near to the one of the holy areas where they have the annual pilgrimage, Hajj. So we actually provided 23 of these systems for the Hilton hotels, the Hilton properties there, really just to provide uh, any air purification because they don't want those food smells in the hotel lobby. So uh, those systems actually just recently were started up. So they've been in place now, oh, probably 6 or 7 years or so. So great application, for indoor air quality. These were top of the line systems that included, auto wash, electrostatic precipitators, followed by grease filters, as well as the absorbent media and the blowers to move all that through the system and all the controls as well. So, very, very high profile application, and we have more and more that we are producing and providing for different regions. But as I mentioned, these systems are very popular, very prominent in the Middle East region. All right, so talk about our lifeguard. As I mentioned previously, when I showed the previous slide of the gas phase filtration, how we monitor or track that working zone or the mass transfer zone. Well, we have now introduced our lifeguard media bed monitor. This is something has been a item on our owner Kevin Jameson's. He's been working on this for many years. So now technology has finally caught up with his mind. So we were able to develop this really just industry first and really only real time media bed monitor. So that way we can actually monitor and end users can monitor the media consumption in real time. So we talked briefly about that. It's using different 6 sensors mounted externally on the unit. So now we can predict when it's time to change out the media. So we can be much more proactive and get that instantaneous media life feedback on the systems. And it can be just easily and seamlessly retrofitted on any existing units as well as our current systems. And we're now with this new design for the lifeguard, we can now install them on side access houses as well. So just give that added uh, benefit and feature moving forward. So again, with the lifeguard media bed monitor, so we maximizing the lifespan of media. So now any end users just can replace the media when it's time. So you don't have to worry about, well, I think that my media needs to be changed, but I'm not sure. And so you may end up prematurely spending money. Where now with the system, you can actually determine exactly when it's time to change out the media. Everything's remote as well. It can be tied to their 4 to 20 milliamp signal. That can be tied into the building maintenance or SCADA as well. It's also cloud-based. So we can design it or set it up or program it to send alarms or alerts at certain media levels. So we have it triggered to send an alarm at when you get 50% media life, they can be set up and designed for that. And this is something that we can monitor here at PureAir. We're also give that access for any consultants or the end users, of course, can monitor as well. So it's really just ensuring that we are being proactive instead of reactive, and you are monitoring the most important aspect of your gas phase system, chemical filtration system, which is the actual media. So very important and very innovative system that we are looking forward to providing all over the world. All right, so I have to apologize. We're going to have I was very excited to introduce an industry pioneer for gas phase filtration, Mr. Barney Burrows, founder of PureFill, again, former ASHRAE president, and just a super wealth of knowledge. But unfortunately, due to some scheduling conflicts, Barney wasn't able to attend uh, this particular webinar, but we are going to, have one here very soon, very shortly, to have him speak and talk about indoor air quality because he's very passionate about it and very knowledgeable. And every time I sit down with him, uh, it seems like I learn something new every time. So even I've been in the industry almost 23 years. This gentleman, his knowledge is awe-inspiring. So looking forward to here shortly, allowing get him on the webinar and let him speak as well and really share his knowledge with everyone else. So, all right. With that said, that is the end of the presentation. I want to see if there are any questions.